Hey, John.
Hi, Madhu.
Yeah, you okay?
I'm here. Okay. Yeah.
We are live. So 1 second. I'm just checking the people are joining. So
hmm So, what is the format? Should we just start introduction or?
yeah. I'll kick off. We are live now. Sure.
hmm
So 1 second. Hello. Good morning, guys. We'll just wait for a minute or two to get more participants, and then yeah, we can kick off. Cool. Just leave me some comments where which country you're from, and yeah. Sharna, Lithuania. Wow, welcome, welcome. We'll just give it another minute, and we'll kick off. Hi, Peter from Hungary. Sombar, hi. Hi, Andras. Richard. Oh, Sziasztok. Jó reggelt. Oh. Hi, Yogi. Jó reggelt, jó reggelt. Cool. I think, yeah, we can kick off now, I would say. Thanks, everyone who joined. Welcome to another session of DevSecOn event. My name is Madhu Kumar. I'm the DevSecOn chapter leader for Hungary. It's my pleasure to host today and get more insights on security topics where you can learn, participate, ask questions on YouTube chat. So those questions will be directed to our StreamYard, so we can see the questions and the speakers will answer them. So the format would be basically, we have the presentation itself, and then at the end of the presentation, we take the question and answers. So we have three speakers today: Shweta, Natalia, and John, in that order. So they take about container constructs from Shweta, security observability from Natalia, and last but not least, cloud security by John. I would like to have a brief intro with the speakers. So I would like to invite Shweta on the stage. Uh, Hi, Shweta. Good morning, good
Hey,
afternoon. I know it's a late afternoon for you, I think. How are you doing today?
I'm doing very well and nice to see you, Madhu. It's your morning, I believe. And hello to everyone who are
Yes,
online.
yes.
Excited to be here.
Cool. Thanks, Shweta. I'm glad to have you on board. And yeah, probably in the intro video, you're going to talk about yourself and the container constructs, what you want to talk about. But I would like to invite my second speaker, special guest, because she's in the studio today. So Natalia,
Hey, good
uh,
morning, good afternoon, everyone.
yeah.
I'm Natalia, and thank you.
So Natalia going to talk about the security observability, and yeah, more details later. So thank you, Natalia, for accepting and welcome on board.
Yeah.
I would like to thank you. I would like to invite John, who's our security expert from T Systems. Welcome, John. How are you doing
Hi
today?
guys. Yeah, thank you for inviting. Yeah, good. Yeah, it's very exciting to talk about security. Yeah, in the morning. Yeah, good. Looking forward to the session for sure. Yeah.
Cool. Thanks, John. All right. Without any further ado, then I will bring up our first speaker, Shweta, to talk about container constructs. So give me 1 second so I can share. And please leave all the questions in the YouTube chat. So it takes some time because we wait for the end of the session. It doesn't mean that we're ignoring them. So we will collect them, and Shweta will come along, and she can answer as well. So please bear with me until end of the session, and then we can answer all the questions. But feel free to please ask questions, put them in the chat, and yeah, we'll pick it up. Thank you. And then now I'm going to switch to the chat. Here we go.
Okay. Containers are built once and run anywhere.
Sorry, guys. Can you let me know if you can hear the sound, please? Is that better now?
Okay. So let's get started with the topic container security must know constructs. What we are going to cover in this topic is container revisit. It's very important that let's understand containers once again, that what entity we are talking about. Post that, we'll see that we'll do some fun and we'll break some security myths. And the last, we'll build the security foundation, in which we will cover 4 must-know constructs for containers. So let's get started. Containers are build once and run anywhere entity. This term is very famous for containers because this truly defines that any container is self-sufficient, which means that it is created in such a way that, bundled in such a way that all its application, libraries, configuration are bundled up in one packet. And this is self-sufficient, isolated, and it can run on any environment. So that's where we say that containers are the entities which are built once and run anywhere entities. What additionally I want to tell you that containers are not a bubble somewhere. They also run on very much on host systems. So containers have similarities with VMs as well as processes. How? I'll show you. From inside, if you look at the container designs are much similar like a VM. If you look at this right side picture, it indicates here that any host OS further gives us the VMs, which are partitioned on the guest OS, and they have their own application and binaries and libraries to it. Similar to that, containers also are bundled in such a way that they run directly on the host OS, and they have this orange and yellow boxes which you are seeing are the binaries and applications which are bundled along with these applications. And what they need minimal is any container runtime engine, which in this case is Docker, but this can be any other container runtime engine, for example, Cryo, Containerd, or any other one. So that's how containers are though isolated, but they also share OS and wherever appropriate, their binaries and libraries. Let's see it in action. Here, what I have done is I'm just running a simple new pod with the image Nginx. Once it starts running, I have opened up a shell for that. So by bin bash shell, I have opened here. And the command which I'm issuing here is df-h, which indicates disk free and in human readable form. What this command gives me the output allocated size, where they are mounted on disk. So this is different from what VM has. VM also has its own chunk or share on any host system. My container also has similar kind of share of the host system or the kernel. Similarly, as you see /bin, if we do, it has its own set of commands and libraries, which it also utilizes. So that's how we can say that container in an indicative form is similar to a VM from inside. But container is also similar or is a process from outside. How? Because if you look at this picture now, the real process, which has its own memory, registers, and processes associated with it, it also has its libraries and binaries which are associated here. The only difference between process and container is that for any other process, it is bundled not in a containerized form. It is not tightly coupled along with the process, but it is shared among many other processes. However, in case of containers, it is limited with some limitations which we put, and we will see that how those limitations or the isolations come rather than limitation. Those isolations being achieved is that we pack all these libraries and binaries inside that container, and that's how it is maintained. But ultimately, this is also a process. Let's see how I'm relating it to a process in practical. So if you run on any system where you have some containers running, let's say I have running here Docker PS, it gives me container IDs, all the container IDs. And if I pick up any one container ID here, what I'm doing is I'm inspecting Docker inspect in the format state.pid. So what I'm trying to fetch for this container ID, the process ID internally hidden but associated with this container. So it gives me 3551, as you can see, and this is the process which is associated with it. So it's hidden. It has one more layer of abstraction to it, which is in form of container ID. But ultimately, this is also a process. Now we have understood that container is build once, done anywhere entity. It is self-sufficient. It is isolated. It is similar to VM. It has properties of process, but then what? Is it secured enough? Is it secured enough that it cannot harm the host system? Or is it secured enough that one container cannot troubled by any other container? So that's the security myth, which I want to break now. And let's have some fun before we understand that what are those security constructs which you need to know. So I'm jumping onto my terminal where my Kubernetes cluster is running. And what I'm going to do, I'm going to run 2 pods here. Let me increase it a little bit so that it is clearly visible. Okay, so what I'm going to do, I'm going to with an image, a simple Nginx image. Okay, so here it started creating. And let's see what is the status of the pod. It's running. So as you can see, my container new pod is running now. What I'm going to do, just from the demonstration purpose, first I'll show you a normal container. I'm going to shell, open std in our terminal, and for my new pod, open me a binary which is bash shell. Okay, something wrong here. Okay, I'm missing a dash. So it has brought me to root at new pod. So I am inside a container now. And if I do ls-l now, I have my available file system to me, that what all files, binaries, libraries I have access to. But if you notice here, I have all the ordinary things which a container should have access to are available to me. There is nothing like which I can do anything to my host system. But now, given this view we have, what we are going to do is, let's come out of this. I'm clearing my screen. Okay. We have understood that it is a normal container and it has all the normal stuff which are bundled up with this container. But what we are going to do now, we are going to run an abnormal container. Let me first show you that what I have. So here I'm writing a YAML file where I'm running a pod kind, and its name is myth breaker because we are breaking some myth here. And it is running again with the same simple Nginx latest image which is available. But what's special here is that I am mounting a volume inside this container, and I am naming it /Kubernetes. But the fun part is the /Kubernetes is actually, I'm hosting from the actual operating system or the host system. I'm allowing that my etc Kubernetes should be allowed to be mounted inside my container. So that's what I'm linking here. On top of that, 2 additional features I'm enabling, which will make me privileged authority on the container. So that gives me rights, which is like security context I'm setting that privileged true. So I have more privileges than the normal container. And I'm also saying that do it on the master node, not on any worker nodes. Don't place my container on any normal worker node, but place it directly on the master node. So with these extra configurations, I'm running this pod now. So kubectl, quickly apply my myth breaker. And here it goes. Let's see if it is in action. Kubectl get pods. It is still creating, and now it is running. So as you can see, one, we have normal pod, new pod, and second is Mythbreaker, which we just created, and that is also running. Now let's enter into this particular pod. And for that same exec command, I'll be utilizing just that I'll be now moving into Mythbreaker pod rather than the new pod. Yes. So here I am inside root at Mythbreaker, as you can see. Now what I'm doing is same ls-l list me all the files which are available to me. And here is the interesting part. I have access to Kubernetes folder, which is nothing but, let me clear the screen, which is nothing but, if I look at ls/Kubernetes, then it has all the contents which are there in the host/etc/Kubernetes, and it has PKI, which means all the certificates are now exposed to this container, which are actually residing somewhere in the master node. Then you have all the manifests which are running on the through the master node. You have kubelet configuration access. You have admin configuration access as well. So let's look at what is there in this admin conf, because that's the key. Sorry, PI won't work here. So I would say cat. Yes, so here my whole cluster information, my certificate authority, my server information, and whatnot. So everything is there at the back of my hand. So I can do whatever I want to do with this data. And that's what I wanted to show you, because we have played around, we have misused container capabilities, and because there are no security boundaries defined around that container. So that's why I'm able to break it and enter into that container with some more privileges, which is actually a wrong thing to do. And that's what I wanted to show you. So let's come back. Now that we have understood containers, though they are isolated, though they are packaged well, but they have got certain authorities, which if misused, can be bad for the host system or for the other containers. So that's what we want to secure from. Now let's enter into that. How do we do it? There are first 4 must-know security constructs, which every technical person who knows about container and Kubernetes should know. First of all, this is SELinux. Second is Namespace, Cgroup, and Seccomp. So let's discuss them one by one. All these 4 constructs, good thing about them is that they are free. They are freely available to you as part of the operating system features itself, which you can utilize, only that you need to know and be aware of them and make use of them. So let's get started with SELinux. Now, excuse me. SELinux is security enhanced Linux, as the name suggests. Basically, it is an access control mechanism. What it does, it labels everything. Basically, the good thing about SELinux is a very simple kind of feature, OS feature, a kernel feature, which is available to us, that it labels all your files, all your containers, and all the resources which they consume. So that's how it matches that who is authorized to utilize what resources. And that's how it restricts. If I'm not authorized to use, let's say, host file system, then it won't allow to do it. Now, what it does, it protects processes from each other, protects host system from running processes. It protects the host file system from container misuses or vulnerabilities. So there are a lot of vulnerabilities which are easily you can catch with SELinux if enabled. For example, this CVE 2016-9962, which is a run C exec vulnerability, was found, and it was caught by SELinux. So now that we have understood security enhanced Linux is a feature, OS feature, we can make use of it. But to make use of it, you need to make the conditions on so that SELinux is activated. The condition which is required is SELinux in this file /etc SELinux config should be enforced. The middle option you can see, it shouldn't be disabled, it shouldn't be permissive. Permissive means it is there, but it is not enforced. So that's also not a good thing. What we should do is SELinux enforcing. Now, it's very easy to disable this option and work, because it at times when enabled, it gives you a lot of pain because it doesn't allow you to do anything wrong in the system, but this is good for production systems. And in general, we should make our developers and ourselves habitual of it to make use of it. So this is one way of enabling it. Second way of enabling it, set enforce. If you say 0, it will disable. If you say 1, it enables it. Or another way is get enforce. So this is what you can use. And if you are interested in knowing a little more about SELinux and want to see that what is the kind of labeling it does, use any of these commands. But to use these commands, one thing is important, that SELinux toolkit should be there, as well as it should be enabled in the system. So once it is enabled and system gets time to catch up on labeling action by doing the restarts and all, it is able to label all the things. So you can see all those label by using, for example, ls-lz. That will show you what all labels SELinux put and how it protects. So this is one service which is very easy to use. Just you need to enable it in the background and it does its job very beautifully. Next, and very important feature which is linked to any container is namespace, because that's what brings the process isolation. So all that magic of isolation we associate with containers, that comes from namespace. Because namespace is kernel can isolate specific system resources usually visible to all processes. Now this is done by placing the resources within a namespace. That's what the job namespace does. Inside a namespace, only processes that are member of that namespace can utilize those resources. So it's a kind of envelope which you create and hide all the resources inside it. Then if you associate various processes or containers inside it, all those will obey the containerized environment or the namespace limitations which are associated with it. Namespace also helps you apply security restrictions to containers. We will see how in a moment. But before that, one important thing I want to tell you, that there are 7 such namespaces, which are Cgroup. We'll be talking about it. IPCs, which tell you, which helps container to know that what process communication is possible among the containers or outside. What is the network allocated to it? What file systems can be mounted, what is the process IDs associated, users, group IDs, and host names. So these are 7 namespaces which you should be aware of. You need not do anything about it, but you should be aware of that these are the 7 namespaces which actually are associated with each and every of your container. And they have their own instances of these 7 namespaces inside it. And that's what enables your containers to make use of host system resources, be it CPU, be it memory, or any other thing. So that's what is important to know. Now to see this in action, just give ls-ns command, which means list all the namespaces. And in the type column, you can see that all those 7 categories which we just saw are labeled here. So it is either Cgroup, PID, user, UTS, IPC, and mount. So all these namespaces which are there and in action are out of those 7 only. Let me also tell you about the container namespace protection. I'm just showing you 2 of the ways, but there are many other ways that can work around namespace. For example, here we are defining a policy where we are saying that user ls can work only in namespace fronto. Resource pods can be utilized read-only nature. So only we are enabling it to read certain resources or utilize whatever is required for in read-only mode. So that kind of policy can be associated with namespaces. Similarly, for any namespace, you can also at the from the hierarchy perspective, namespace level, you can define wherever inside you have your pods or the containers defined. You can say that how much of CPU and memory can be overall consumed by my namespace. This is to restrict that beyond this limit, my containers should not be able to eat up on my resources or the host resources. So these are two of the ways, but there are many other network policies and other things where you can include the namespace and it restricts the containers. So this control group is very important namespace construct because control group is the one which actually limits at the runtime that how much of CPU and memory you can utilize. So this comes into the action. This is another namespace which is associated with your container or a pod, and it comes in action at the runtime. So it makes CPU aware that how much of containers can utilize. Container options, some of the container options, as you can see, that CPU share, CPU set CPUs, and some more things, which in practical way, we don't utilize it to, we can set it if we want, we can set it from command line or through YAMLs, but usually we don't touch that. We don't touch those things. We have pod restrictions or inside the pod, you can have your limits and the resources defined, and that's what take care of that you will be limited by the resources. But you should be aware because Cgroup is something which was created, if I'm not wrong, in year 2006 or so by Google, and they named it as process containers. That was the idea behind that. How do you limit your containers and still this works as a process? So this is one key feature behind the scenes which you should be aware of. Next, and very important feature is Seccomp. Seccomp stands for Security Computing Mode, but I'll come to that. However, this feature is related to your system calls, because whatever in Linux kind of system, any interaction happen, processes are able to achieve anything by using those system calls, and roughly around 400 system calls are there in total. However, each system call is a facility as well as can be source of potential attack on kernel or running processes. So we need to be very well aware that what system calls should be enabled for us. For any container program, 20 to 30 system calls potentially can be required or even lesser. We will see in few moments that why it needs to be lesser. If containers utilizing more than this, then there is something really wrong with those containers, or somebody has increased their privileges, which can be very, very harmful for the system. So we need to be very well aware of it. All in all, Seccomp is security mechanism to restrict these system calls that a program may make. Let's understand it in little more detail. As I said, Seccomp stands for Secure Computing Mode. Now, the main page definition says that it itself is Seccomp system call operates on the secure computing state of the calling process. Seccomp limits how processes can use system calls. Of course, that's the main purpose, because secure computing mode tells you that how much of system calls you are authorized to make, and that's what it limits. It defines security profile for processes, whitelist the system calls, parameters, and file descriptors. Seccomp defines which system calls should and should not be allowed to be executed via containers. And that's where we are relating it to container, that what containers are allowed to do in their isolated mode and what they are not or should not. It restricts the calls a process or container able to make from user space to the kernel space, because we don't want to exploit the system. But if you remember, we misused in our demo by enabling ourselves to privileged mode, and then we actually utilized more system calls which were available to us, which is not a good practice. Let me first show you in kernel context. If you simply run this command, cat/proc syskernel and cap last cap, so that will give you the number of system calls enabled at the moment for your kernel. If you want to see them, if you're interested in knowing more about them, then they give this command cap-sh dash minus print, and it will give you all the bounding set which is currently operating for your kernel. So as you can see, all these comma separated, but all of them starts with cap underscore, for example, chown, DAC override, cap net admin, and there are many more. So I'm not going to talk about every one of these, but just to show you that what is enabled for us. Now, if you are interested in knowing that for your process or your container, what are the capabilities or the Seccomp capabilities which are there, then just give cat/proc process ID number, where in this case 94 is the process ID number /status, and just grep on the cap. You will see 5 parameters coming. First one is capabilities inherited from your kernel or your host OS, capabilities permitted, capabilities effective at the moment, and bonding set and ambient. We are not interested in all of them, but permitted and effective. And if you pick up any of these permitted or effective and decode it with the cap-sh -- decode and this value, then you will see that for this process, how many of capabilities are, or the system call capabilities are enabled at the moment, which may or may not be desirable. That's what we want to restrict on. Now, relating it to containers, because we are talking about all premises around the containers. In containers, there are 2 ways to define it. You can say that in your spec security context, where Seccomp profile should have runtime default, where whatever is defined by my system, I'm just inheriting it. That is one way of doing. Or second way of doing is that I don't want all those 37 to be available to me, right? 37, 40 or whatever is available to my host or kernel. So I want to restrict it and very minimum one which I want to expose to my container. So you can have your local host profile defined, where you can say profiles, fine-grained or whatever name you want to give, .json, and just mention the capabilities which are required, and it will do the needful. Okay, so here we come to the end of this discussion, but just winding up quickly on this, we saw that containers are isolated and self-sufficient units, but it doesn't ensure that they are secure from other containers or they are not doing any harm to your host operating system, because ultimately they are running on your same operating system where other things are running. So you need to be aware of these 4 constructs, which are free of cost, and you can make use of these things. First is SELinux, which just by enabling, and once this whole thing runs and labeled the system, it takes care of all the vulnerabilities or all the excess issues which may occur through vulnerabilities or through programming errors or whatever. It restricts all those. Second is Seccomp, which is a system call mechanism where it restricts that processes can use which all system calls at the runtime. And this can be restricted not to too much empower our containers, and this should be utilized. Then namespace is the process or container wrappers, as we saw by having those 7 namespaces. There are various privileges or various features associated with namespace where you can define policies, you can restrict through namespaces, and you can make sure that your containers are utilizing what they are supposed to be utilizing, not anything more than that. And Cgroup is the feature, which is again a namespace, but it works behind the scene and it makes sure that your CPU and memory are used honestly or legitimately by any container or a pod. So with that, I come to the end of this session. Let's look at the questions.
Cool. Thanks, Shweta. Well done. Well done. That was a very interesting and insightful session. Thanks. I would like to bring the questions on the screen. So if you could answer them. The first one is from Mohammed Amar. He asking basically, what does security context privilege do? I mean, does it go unwanted, give unwanted rights to the container on the host?
Yes, certainly. So, Mohammed, what happens when you say security context to privileged? Uh, when you before coming to privilege, when you create a container file, when you define that, okay, I'm creating a container file, it will have these libraries or what I'm packaging from my application. By default, system associate root access to that, which is at some level. Now, when we say in our YAML file on top of when we are running it on Kubernetes container orchestrator or Kubernetes platform, if we are saying privilege, that is even more than the root privileges. So, which means if at the definition level you are saying root for some reason, and when you are creating your YAML file and you are taking it to privilege, it means you are even enhancing their capability. And it can be definitely, I mean, using this, we saw that we were able to get into the host operating system and get all the admin configurations, all the certificate information, encryption information, etc. So definitely it is harmful. And how to restrict it, that's very important. I mean, the best practice says that if you can restrict it at the time of defining your container Docker file itself, be very specific and say that so and so user and so group should be able to do all these operations which you are defining in Docker file. So that is the best practice. But at times you need to give root, but definitely go away with the privilege and make it a practice in your projects that don't use privilege security context. Hope that answers your question.
Cool. Thanks, Shweta. So we have another one from Mohammed again. So he's basically asking, when you say we have enable SELinux, so are you talking about enabling in the host system or in the container?
Okay. Yeah. Good question. See, SELinux is a operating system construct. So you don't enable or disable it at the container level. So definitely you need to take those commands which we saw. You need to enable it at the OS level, and then it has various authorities, container underscore T, and various other labels which it associates at the container level. It does its job because for SELinux, it's like any other process and any other files which are associated with that process. So what container is able to utilize and what resources it should consume, by labeling and matching those labels, SELinux does its job, but it is at the OS level. So that's the
Cool. Thanks,
answer.
Shweta. Good answer. Good answer there. Sure, cool. So there's another question from Anthony. He's basically asking, can these tools be added to AWS hosted containers? For example, I mean, I can extend a little bit. You know, we have Elastic Container Service, a Kubernetes service in the hyperscalers, right? Or Azure or GCP. Can we add these tools in those cloud native way or any other way?
I'll tell you, based on my experience, I might not be able to fully say that yes, it is. You can do it for ECS or Fargate or all those things. But when you utilize AWS EKS service, and if underlying host you are taking is Red Hat Linux, or if you're not going with EKS and you're going with AWS ROSA service, then yes, certainly, because Red Hat OS has this feature by default, but you need to enable it as we discussed. But I would need to check if you go with AWS Linux whether you can do it or not. I think I have not checked that, but I mean, logically speaking, it's a Linux platform. You should be able to use it. But if EKS brings its own dependencies or restrictions, that is something I'm a bit conscious about and would not like to say that everywhere you can use it.
Yeah, sure. Yeah, thanks, Shweta. Thank you. Just looking at the chat again. So, are there any other questions from anyone? Please feel free to add because we still have some time for Shweta for the questions. Yeah, just to extend a little bit on this AWS hosted containers. Any managed service you take from hyperscalers, the underlying infrastructure is completely managed by the hyperscaler itself, like AWS or Azure. So you will not have a full privilege on how they run. For example, on the control plane level, you just have access to the control plane, but you don't have access to the server where the control plane or Kubernetes server is running. Yeah, so they give you an endpoint, and then basically you can play around. You will have full access to it, to how you want to run it. So there might be some certain limitations what and how you could do, but I'm also not sure if you could implement these tools on a cloud native way. But yeah, good question there. Thanks, Anthony.
Good question. Yeah. Okay.
Okay. In that case, Mohammed is happy with your answer. Thanks, Mohammed. Cool. Is there anything else you would like to add, Shweta, from your side? Like, we talked about containers, we talked about, cgroups, we talked about this 4 important constructs. What is that? What is the takeaway from your talk, right? So what is that guys have to take away from your talk? What are the key factors that you would like to pass the message?
Good question. Good that you're allowing me to summarize it, Madhu. That I would say that container, we discuss it's isolated, it's self-sufficient, but it has layers to it. It runs on some infrastructure. So definitely security also comes in various layers. But I believe if you know that how container is a container and not any general process, that is very much essential for you to know, so that you can save it from the external world or save a container to do any harm to your operating system. That is one point which I tried explaining in my talk. And second aspect is these 4 constructs which I spoke about today, and specifically I wanted to do that because these are free of cost and you can use it very easily. And you need to be aware whatever security tool you put on top of it, which is paid or unpaid, these are something which will play under the scenes. So it's always advisable that be very well aware of that what can happen to your system at the container level. So that's the summary in nutshell.
No, that's a good message. Good message. Yeah. So fix the problem before it even occurs, right? So yeah. So yeah, that's a great message, Shweta. Thank you. I don't see any other questions in the chat for you. And yeah, that's a fantastic talk. I love myself as a container guy. I definitely learned some new aspects in those constructs and more technical deep dive. So thank you, Shweta. It's a really great insight and very well done. And thanks for the audience who asked the questions as well. Thank you, Shweta.
Yeah. Thanks. Bye.
Okay, the next session would be again, we have our important guest, Natalia, in the studio, where we can kick off the security observability session. But before I do, I would like to test the audio issue. If you bear with me 1 second, I would like to test something, and then just please let me know if you could hear, and we can. I will try to start that. Yeah. So give me 1 second, please. Okay. Can you give me a okay thumbs up if you can hear the sound, please? Can you hear the sound, guys? Not yet. I'm just checking if you could hear any sound. Oh, yes. Fantastic. Thanks, Georgi. Thanks. Okay. Okay, fantastic. Okay, so maybe this will fix that sound issue. So now I will bring on Natalia. So 1 second. Okay, here we go, guys. So over to Natalia.
Hello everyone and welcome. My name is Natalia. I'm I'm a security engineer here at Isovalent, and I have been working a couple of years now on security observability and runtime enforcement with eBPF, both on production environments with customers and clients, and on open source environments with the community. So in this talk, I would like to present how can we secure cloud-native workloads with the help of eBPF and the new open source project that we call Tetragon. So a little bit about the agenda. In the first section, I would like to talk about what is the activity that we care about when securing a cloud-native workload, and what is the activity or the events that can be useful for a security team during an incident investigation or threat detection. Then we will jump directly into how can we spot this activity and then potentially block it with runtime enforcement. Then I will show you an open source tool that we are creating here at Isovalent. It's called Tetragon. And then we will see a quick demo on workload runtime visibility. So let's jump in directly into security observability and then into the events that we care about when securing a Kubernetes or a cloud-native workload. So this is a list of events that can be useful when we are spotting or detecting or reporting any kind of malicious activity. And then these events are basically answering questions like, what were the network connections that were made during a workload lifecycle? What were the processes that were executed? What were the files that were accessed? What were the capabilities and the namespaces that the process started with or maybe gained meanwhile? And then what were the sensitive system calls that were made by a Kubernetes workload? So there are already existing solutions to be able to spot this kind of malicious activity. These solutions were created in the past, and then we will take a look at each of them and then compare it with the solution which is eBPF-based and then that we are creating here. And then we are going to deep dive into Tetragon, which is an open source tool created by the creators of Cilium. So this list includes LD preload, pretrace, ptrace, Seccomp, LSM, LSM eBPF, and then finally eBPF. So the first one is LD preload. This is the oldest approach. With this, we are able to load a library into an application without any awareness or changing that application code. So we are essentially injecting that library into the application and then watching all the system calls that the application is performing with that library instead of using the kernel. So this is called LD preload proxy or system call proxy. This is great, but this can be actually bypassed. So if the application is statically linked, then LD preload will have no effect. So we will lose all the visibility into system calls, and then any kind of enforcement will be ineffective. So this is already abandoned from that perspective. The next is we can do system call checks within the kernel. So we can do system call checks when we enter to or exit from a system call at the kernel level. There are well-defined hook points in the kernel for tracing entry to and then basically exit from a system call. You can hook into these hook points with ptrace, Seccomp, and also Seccomp profiles get evaluated here. And then you can also hook into these hook points with trace points or query probes to run eBPF programs. So this is already so much better than LD preload because the application cannot actually bypass it easily with the injection of the library. But this is vulnerable to so-called TOC, TTOO attacks. This is time of check, time of use. So the hook point when the solution sees the system call is before the last point when the application can actually change it. So you can see it in the picture. The hook point is actually at the system call entry level, and then the system call handling copies the parameters from user space to the kernel, and then it's still possible for an application to change it to something else after the checks. There are a couple of references here. The most well-known is the Phantom attacks, which were presented at DEF-CON 2021. So to be able to avoid top 2 attacks, we need to make the checks at the right place in the kernel after the kernel copies those parameters. There are already existing solutions that are doing this, and there is a well-defined interface. It's called LSM API. LSM stands for Linux Security Modules. So it's a relatively old API and then allows to do security checks and enforcement at the right level. It is relatively stable, a safe place to make checks, but it requires additional kernel modules to load, and then it's static. So LSM is used by Apple and SELinux to check system calls against existing profiles, and then, for example, behavior, so which file can be accessed by which programs. And then a better known or better suited is BPF LSM. It uses eBPF to make LSM dynamic instead of the existing static solution. So it's a step forward and almost what we are creating here at Isovalent. So these API calls are already in the right place, and it's designed to be like in a high performance. You get access to the kernel data structures, which are already pre-populated with the right data, and then you can do the security checks at the right place. But it requires relatively new kernel modules. BPF LSM was introduced in 5.7, and then most of us using kernels in production environments older than that. And then it is also limited to hook points only that LSM provides. And then if you would like to introduce new hook points, then you actually need to change the kernel code. So that's why we created Tetragon. We want the same property in terms of safety, hook points, and security than BPF LSM, but we want to avoid additional kernel requirements. So we will be able to run like on older kernels, and then we would like to be able to add additional hook points rather than the one that you can find in LSM. And then we would like to have a shared state between BPF programs with BPF maps. This is basically the yellow database that you can see it in the pictures. And then this allows multiple eBPF programs to work together. And then it also allows in-kernel filtering, which is basically gives you a really high performance. So this is where we arrive to Tetragon. Tetragon is an eBPF-based solution providing combined runtime and network security observability and runtime enforcement to Kubernetes and cloud-native workloads. It runs on the top of the Linux operating system. It can be Kubernetes, cloud-native environments, or bare metal VMs. If it's a Kubernetes environment, it runs as a daemon set, and then if it's a bare metal VM, then it runs as a container. It uses eBPF programs to collect the events exactly you define directly from the kernel, and then you can basically filter with very high performance what were the processes, networking events, or files that you would like to collect, and then what are the circumstances that you would like to be able to detect, for example, namespaces and then capability changes. And then all of these events can be traced by security policies. The security policies are dynamic. You can load them anytime without, for example, restarting the application or the pod. And then the pod doesn't even have to reach the ready state for the policy to take effect. So with these policies, we are able to observe arbitrary events inside the kernel. Right now, two main types are supported, kprobes and then trace points. And then with kprobes, we are able to observe arbitrary functions and then system calls inside the kernel. So in the following demo, I would like to show you how privileged pod starts and then opens its password, and then how it can be traced and then blocked by an eBPF-based solution, which provides security observability and runtime enforcement. So here I have 2 terminals, and I already have a GK cluster set up and running, and I already deployed Tetragon. We can check the nodes. And then it should be kernel 5.10. And then what I'm going to do, I will apply a test pod on this cluster, and then I will try to edit the EC password file. And then I already have a security policy applied, which should block the syswrite system call trying to edit this EC password file coming from that test pod. So I will start observing the events from this pod via CLI. And then I'm going to apply this test pod. And then it will take a couple of seconds for the image to download, and then we should be see a bash terminal already. I kubectl as execting already, and then let's try to edit the EC password file. We already see the bin bash and then also the bin groups process that were executed. So let's try to edit EC password. And then we already see some open and close events on the bottom coming from the EC password file. And then let's just try to add Natalia. And then try to close it. And then we already see the write event on the bottom. We saw the binary name, we saw the file name, and then actually that 930 bytes were tried to write to EC password. And then we already see the exit event with a signal that is secure. So with this, I would like to say thank you also on the behalf of the Tetragon team. And I would like to open this discussion for a Q&A.
Cool. Thanks, Natalia, for the wonderful session there. So I'm just checking if you have any questions from the chat, or I don't see anything. Anybody want to ask any questions, or
Everyone
anything
is speechless.
Yes, I think so. But I just would like to ask, what is that you would like to have like a takeaway from your speech that we should concentrate on, or maybe what is the giveaway from you to the audience?
So I just wanted to give like a quick overview, like what are the events that can be helpful for a security team during like a container lifecycle or a cloud native work lifecycle, and then basically how can you monitor it with existing technologies, and then why eBPF would be the most optimal to do it.
Cool.
Yeah.
Arel, good comment. I think we also have a plan to arrange a follow-up with Natalia. I will bring her back again for sure. If you need a more detailed version, I know it's a little bit short and sweet with a lot of information to digest. Probably I might arrange another session with where we can go a deep dive on the talk.
Sure, we can do like a more detailed one for like 30 minutes or like over an hour. Should be fine.
Yes, she is, I think, yeah. Yeah. I think, yeah, Mohammed and the rest, yeah, are probably I'll set up another session, deep dive in this chat, obviously, and we can drill down. There's a survey at the end of this talk session, so please feel free to mention what would you like to hear from Natalia in the next session. So maybe she can, help us prepare and share more insights there.
Also, if you would like to need more like introduction or like more details around it, then I can probably deep dive.
Yeah, sure.
Okay, thanks a lot for inviting
Cool.
Madhu again.
No problem. Thanks, Natalia.
Thank
That was
you,
a great
guys.
session. Cool. Yeah, it's a little bit complicated for me as well. Even I know containers in and out, I still felt very refreshing with that session there. So thanks, Natalia. That was really great, really great. So cool. As I promise, I will set up another follow-up, and yeah, you guys can let me know what you would like to hear from Natalia on that security perspective, observability, yeah, whatever comes in your mind as part of the session. Please leave those comments in the feedback form, so that will help me arrange a follow-up session with Natalia. Okay, in that case, we're good on the time. I would probably bring John if there's any other questions. I think everyone is speechless with that. So yeah, thanks guys. And let me bring in John then. 1 second. All right. Okay, so let me know if you guys can see the screen and also probably can hear. But yeah, over to you, John.
Good morning, everyone. My name is John Matthew George, and today I got an opportunity to speak on a security topic, which I hope would be interesting for all of you. And just before I start, I want to give you a short introduction about myself. My name is John Matthew George, based in Bonn, Germany, and working for T-Systems International GmbH as a cloud solutions architect, mainly focused on the security part of it. And about my experience, I have almost 15 plus years of experience in IT and almost 7 years of experience in the security portfolio. Usually helping customers to come up with a secure design for the applications, for the infrastructure, and that's what I support with. So today, I welcome all of you to this session, and I want to thank the DevSecOn team and T-Systems International for creating such an event where we can share our thoughts and ideas and connect the community together. And so, yeah, before we spending a lot of time on introductions, I will directly like to jump onto the topic. So the topic I want to talk to you today is AWS as a cloud platform secure for mission critical data or sensitive data. So, and this would be focused on what we should know, what is a cloud, right? And how we can make sure when we move our data to cloud is secure. So this would be a very basic session talking about different layers of security that we need to implement for having a secured environment for us on cloud. And yeah, looking forward to it and hope you guys have a interactive session. We will have some question and answer rounds at the end of this talk. We will be happy to answer any of your questions. Please feel free to ask me as many questions as you want. Or if you are interested in any topic after this session for the next topics, next talks, please feel free to just let me know as well in the chat or in the comments, so we can arrange another session for you or have a deep dive on any of the topics. Good. So let me start. So when companies try to move to cloud, there are a lot of questions, and especially if it's a financial sector or health sector or public sector companies that deals with critical information, but that deals with sensitive data, yeah. And they said, okay, I mean, is it really feasible for me to move to cloud? So they are, okay, I don't know where my data is stored. How can I control it? Do I have transparency on my data? Does AWS have access to data? Can they tamper the data? What should I do to make sure my data is compliant to the local regulations? Yeah, for example, if you're in the EU, then you have to make sure you comply with GDPR and all these Schrems 2 and all these things. Yeah. So how can I make sure I comply to that? And how can AWS help me in doing this? So there are a lot of questions, yeah. So today I want to touch on a few topics that would enable you to make sure that your data is secured, you move it to cloud in a secure way, and you manage it and make sure you comply to the regulations. So let's start. Previously, traditionally, when people used to talk about security, there was this concept, okay, we have to be secure, yeah. So, but we cannot move fast because we cannot change our environments so fast because we need to maintain our security, right? We have to buy bigger equipment, you have to change your hardware, your IPS, IDS devices, because as the latest versions come in to improve, make sure the security is in place, and the latest softwares don't really support it. So it was always a struggle in the past to move very rapidly to the next step of the applications or deliverables. Yeah. So, but nowadays, as cloud has evolved and giving customers a lot of flexibility and options to move to cloud, now people are trying to move fast and still stay secure, and that's possible, yeah, because people have nowadays containers and they can kind of containerize the application, they can move everything to cloud, and it's so easy, and you can build in security within your framework, yeah, into your CI/CD pipeline, into whatever you do, you can have the security in place, so you can make sure what you build as the end product is always secured. So, and now the question is, okay, I know all these things, but how can AWS help you, help me, or help us as an organization? Yeah. So that is the question I want to answer today, and guide you basically on how they can be enabled. So just to give you a few examples, yeah, of use cases we have for financial sectors and healthcare, there are a lot of companies on cloud, on AWS, yeah, as a trusted platform provider, right? So you have NASDAQ, Dow Jones, and you all see all these testimonials. I mean, you can go to the testimonials webpage where we can see, okay, there are a lot of companies using AWS, yeah, financial, healthcare, and these critical systems on AWS, and how they're doing that, yeah, how they are making sure their data is secure. So this is just an example to show that people are using AWS for using their hosting or delivering services for the critical and critical content, yeah. So the first thing that I want to come to is AWS supports variety of standards of compliance, yeah. So if you talk about SOC 2, if you talk about CSA, PCI, HIPAA, ISO, I mean, you talk about all these compliances for different countries. AWS is certified and compliant to a lot of compliance requirements, yeah. And they keep on renewing their compliance, having the audits on regular basis. So this gives you a kind of a trust, saying, okay, they are being audited by a third-party company, and it's certified, and that gives you kind of, yeah, a bit more trust onto the cloud provider. Yeah, that's the first part, I would say. And these compliance programs, you can check that on the AWS website. It's publicly available. You can even download the artifacts. So you can, if you want to say, okay, I want to know how it's PCI compliant, what our checks have been done, you can download these artifacts from websites, from AWS. Yeah, so you can go to AWS artifacts and you can download it. It's publicly available. You can have a read through it and see what all checks have been made, and the compliance checklist. Yeah, so that's really amazing, and that gives you a bit more transparency from an AWS perspective. Yeah. So the question is, how can I protect my data on AWS? Yeah. So the first thing is you have to design your architecture in a way it's secured. Yeah, because AWS, as you all know, is a cloud provider. It works on a shared responsibility model. Yeah, so AWS is responsible for the physical infrastructure, the hardware, all these machines physically, as well as the managed services layer. But whatever you build on top, it's your responsibility. So it's our responsibility, so your responsibility to make sure you design the architecture in a very good fashion that's very secure. Making sure there's security groups are in place, and making sure you have firewalls in place, you have all these security tools available, and designed in a way that it's much more secure. And then you have to make sure, okay, when you have designed the infrastructure, you move do migrate the infrastructure in a secure fashion to AWS. And also making sure you have proper encryption in place, which is really a big topic nowadays. I'll come to that in a few minutes. You have mechanisms in place, you have good logging and monitoring in place, and the security should be built in within your pipelines. So if you take care of all these basic concepts around security, you can really make sure that your data on cloud is secure. So let's jump on to the next topic, is what all services are available as a customer for me from AWS. So AWS has a lot of services. They have more than 200 plus services. So you have to know what you can use to make sure your environments are protected. So this is just an example of AWS security services, so that you can use to kind of design your architecture, making sure you have proper detection, monitoring, alerting, and remediation and automations in place. So you have things like Security Hub, CloudTrail, Macy, Detective, all these nice services, then that you can combine together and to have a very, very secure environment. So this is the NIST model that I'm talking about. Very, very useful, and there are a lot of nice tools that can allow you to automate your incidents, automate your security, but it has to be done in a proper fashion. So let me come to the talk about services that allows you to protect your data, that you can use to make sure your data is protected. The very first topic is confidential computing. So that's a very interesting topic, and how we can make sure the virtualization layer is secured, the computing, the networking, and the storage, all these layers are secured. So confidential computing is a concept that AWS is working on, and they started developing Nitro processors. So I will come into the details in the next slide. I just want to quickly go through different services that really helps you to make sure that your data is secure. I will talk about the details of these services in the coming slides. So AWS Nitro is something you would like to remember. AWS Nitro provides you with confidential computing, providing segregation between different layers, and providing more transparency and security to the customers. Then we talked about encryption. So we have to make sure when you do, if you want data to be more secure, you have to make sure everything is encrypted. So encryption of all services, in rest and in transit. So make sure that your S3 buckets are encrypted, making sure your storage is encrypted, and if your databases are encrypted. So just make sure that everything that you use on AWS is encrypted. And we talk about the details on what different kinds of encryption that you can use on AWS, and different layers of security in coming slides. And the next thing that we want to make sure is that you anonymize, or make sure that you don't put any personal information on cloud. Making sure you anonymize your PII data. That's what I want to talk about. So and how you can detect it, and making sure, you anonymize it. So there's a service called Amazon Macy that allows you to scan the contents of your files and folders and everything, and then making sure that you get a good view. Okay, do you have credit card information? Does the data have email addresses, phone numbers, or any XYZ parameter that you want to make sure that your data doesn't have, or want to get some visibility onto that personal information within your data? That's possible with Amazon Macy service. Yeah, so that is something that that's very interesting. I will talk about it as well, and that would give customers a good insight on personal identifiable information. Yeah. Then the very important thing, yeah, is make sure your secrets or your passwords or everything is rotated and it's in a secure fashion. There should be no hard-coded secrets in the code, and everything should be managed securely and rotated in frequent intervals so that it's always safe, yeah, and there's no attack surface. That's something that we need to make sure it happens, and AWS Secrets Manager would help you in achieving that that part of the compliance, yeah. And the fifth point that we need to make sure is we enforce policies and tagging strategies. So one of the recommendations I always give to the customer is, from the start, you have to make sure within your code base, when you trigger an infrastructure or any pipeline, you have to make sure all the resources that are being spent should be tagged with the recommended tags or according to your organization policies. Yeah, there are multiple benefits of tagging. First of all, you can keep a track of your cost. Yeah, you can keep it track of security. So you can, if you want to automate stuff, okay, there's incident and you know, okay, this happened on this particular tagged environment, and this is talking, and you can actually automate the entire incident management using tagging. Yeah, you can enforce policies using tagging. So if you say, I have a set of machines for tagged development, yeah, or tagged finance, and I can put policies. Okay, these machines should only be accessible by the team members of this role, or by the team members. Yeah, or you can use tagging to automate certain processes. Yeah, just restart these sandbox tagged machines after 6 p.m. Yeah, so that's something you can do infinite lot of things. Yeah, using tagging if you have proper tagging strategy, and enforcing policies is something that I would say that's something very, very important, that you need to make sure that you close down things that you don't need. And for example, services that you don't need. So allow users to use only services that are required. Yeah, for example, EC2 or S3 or WAF or whatever. So there are a lot of services. Yeah, so you only allow certain services that are used within that account or within that organization using the policies. Yeah, I will come to the details as well. And also there's a service called AWS config. Yeah, so where you can actually define a configuration. And you say, okay, I want my organization to be compliant to these standards. Yeah, then you set up that template, and you can define that template within for your organization, saying, okay, I want my organization to be PCI, for example, just an example, yeah, compliant. So you can define a template for certain rules. Okay, these are the PCI rules that I want to make sure that all my services are compliant to that. So, and then you apply that compliance on the organization level. And as soon as any service is launched or triggered that doesn't comply to the compliance requirements, it would be flagged as non-compliant. And then you can trigger basically remediations to auto-comply it or make sure that it's automatically remediated. Yeah, just a example. And then you can fix the compliance. Yeah, that's automatically can be done. Or if you want some manual approvals, it can also be done. But you can make sure that you have a transparency on your environment, saying, okay, my environment is compliant or not compliant. Yeah. There are a lot of templates available as well. So if you have a certain requirement, a PCI, HIPAA, or any compliance standards that we talked about, and you want it to be compliant, for example, to CIS benchmark, we can just select. There are a lot of templates. You can select the template and then making sure that you apply it to the organization level, and then you will get more visibility on the compliance of the organizations. Yeah, that's the fifth point, and the last but not the least is a very important one, is that we should continuously monitor our environments for security, as well as making sure we get alerted on time. There's a proper incident management workflow. There's automations in place to make sure that incidents are remediated and alerted at different levels. So that's part of basically a very secured operational workflow. Yeah, so that we have to make sure all these things are in place. AWS provides a bunch of services for doing it. Yeah, so I mentioned a lot of services, a few services here, but in the previous section, I told there are a lot of services that would enable you to detect incidents and automate incidents. Yeah, so I will touch few of them in the coming slides, but I would recommend you to go to the AWS security website and go through these services, the amazing services that would help you to get insights to security incidents and how to deal with that. Good. So let me move on to the interesting topic, Nitro. So Nitro is a confidential computing platform developed by AWS, and now most of the EC2, latest generation EC2 machines or AMIs are using the Nitro in the backend. Yeah. So what is Nitro? So what they have done is they have taken the hypervisor and they have segregated different components and taken out different components out and created different layers. For example, create physical separation between EC2 and network and PCI and storage. Yeah. So there are multiple PCI cards that are being used for EBS. There's a PCI card for VPC. And there's a security chip as well in between that makes sure the calls between EC2, the hypervisor, and the network PCI Express card is always secured, right? And there is no communication happening that's not authenticated or secured, yeah, using encryption. So all these things are happening, and I mean, I would recommend you to go to the AWS Nitro website. We'll give you a very big detail on the architecture. And the best part is now that you can use it. Yeah, you can also enable Nitro enclaves for having compute environments totally protected and secure for highly sensitive data. Yeah, so it's a kind of AWS support personnel don't have access. There's no human access on that environment. It gives you a big confidence that it's certified by FIPS as well. So you can make sure that this is very, very secure. Yeah. And there are only certain limited API operations available on these platforms just for updating the software and certain operations. So I would say even the AWS support team doesn't have any access on this this architecture or these hypervisors. Yeah, so it's very difficult for them to. It's not even possible for them to basically get access to customer data if you are on this this kind of architecture. Yeah, so that gives customers a bit more confidence. Yeah, that's okay. The data is more secure, and there are evidences as well. And I would definitely encourage you to go to the website and list it here and get more glimpse onto that. Good. So let's talk about the interesting topic for me is encryption. Yeah. So encryption, it's very important that you encrypt your data. Yeah. Encrypt everything as much as you can on cloud, and that's very important. Yeah. I would say all the files, objects, S3 buckets, storage, databases, encrypt everything, and don't leave anything unencrypted. Yeah, that gives you more control on your data. Okay, so now the question is, okay, who holds the keys? Yeah, so what are different types of encryption that I can use? Basically, there are three options for you when it comes to encryption. Yeah, so the very first option is using KMS, and that's the very simple way of doing it. It's a service available, the key management service is available out of the box. You can use it, and using that service, we can make sure that your data on AWS is encrypted. Yeah, and it's a very convenient service. Yeah, easily integrated to AWS services. And the next option that you have is using Cloud HSM. So basically, the Cloud HSM is a hardware module in AWS data centers, FIPS certified, and you get a virtual part of that hardware module, and you have full control. The customer has full control on the Cloud HSM. They can create the master keys and then use those master keys to generate data keys and encrypt your S3 buckets or databases or whatever your services that you use. Yeah? And so that's the second option. Yeah, both the options that you use, KMS or Cloud HSMs, are both FIPS certified. Yeah, so it's industry standard for hardware security modules, and it's being audited on a yearly basis. So it's secure. Yeah. And the third option is something, okay, you say, okay, no, I mean, the keys that I use should be owned by me. Yeah? I don't want AWS to hold the keys. Yeah? So even if you use KMS or if you use Cloud HSM, still the keys remain in AWS. Yeah, you say, okay, no, I have critical workload, sensitive workload. I cannot have AWS access to my keys. I want my keys to be with me. Yeah, that's the way people used to work before. Yeah, so I think that's still possible. Yeah, so AWS provides you with the third option where you can bring in your keys onto cloud. So if you say, okay, I have my own hardware HSMs in my data center, yeah, I can get the keys from there and use those keys on AWS. Perfect, that's also possible. So you can bring your keys, you can generate a master key in your data center, use that master key to generate data keys, and you can, I would say, encrypt data keys, and use those data keys to connect to those services. Yeah, so that's possible. And if you're very concerned about the keys and how it's managed, you can use that. So that's one part of it. But there are, I would say, that's the security aspect of it. It's more secure if you think if you don't want AWS to have access to it. But there are some what do you call cons to it. Is like the keys, there would be a slight delay because the keys are outside the database infrastructure. So you have to make sure you have a good connection between the AWS and your HSMs. So it might be either a what do you call a direct connect or a IPsec VPN, whatever you want to use. Yeah, but you should have a good bandwidth. And the other thing is like you are responsible to make sure that the network connectivity is up and your HSMs are able to deliver the queries up to the requirement of these services. Yeah, so that if you are encrypting data, decrypting data, and you have your master keys in your HSMs, you have to make sure your HSMs or the software that you're using is able to resolve the queries in a good fashion on time. You know, otherwise it would have issues. So just make sure that happens on time. So, and if you're able to do that nicely, in a nice fashion, it would surely work. And I've seen customers using those solutions, and yeah, so I hope it works for them in a nice fashion. Yeah, so yeah, that's a third option. Yeah, so making sure that you can encrypt everything, encrypt as much as you can. Yeah, on cloud, and making sure that you have monitoring in place to make sure there is no encrypted, unencrypted objects or services or lying around, and making sure that everything is automatically encrypted at launch. Yeah. So that's about encryption. The next thing is to making sure to use the SSL certificates, to making sure that everything is secured. Along with encryption, you have to make sure, there's SSL in the transit. There is everything is secured. Yeah. So we talked about what do you call security at rest and security in transit. So making sure that you use proper certificates in place. So you can use Certificate Manager, AWS Certificate Manager, that's a service to generate public CAs or private certificates or public certificates according to your requirement. Yeah. So if you're using it for a website and you want to have a public CA that's available, or if you just want for talking within the application, within your internal environments, please go ahead and use private CAs, and making sure that everything, all the communication that you do is secured and authenticated. Yeah. So there are, and this service, the Certificate Manager, is compliant to a lot of compliances like HIPAA, SOC, ISO, PCI, etc. So the underlying architecture is really, really secure for you to use. Yeah. Okay. The next topic that I want to talk about is Amazon Macie. Yeah? So Amazon Macie gives you, as I told in my previous slide, gives you visibility to personal identifiable information. Yeah? So you can configure Amazon Macie to detect credit card information, email addresses, phone numbers, bank account details, whatever. Yeah, within your S3 buckets, and you say, okay, you can actually get a good view of it. How does it look like? How many? And then you can automate that. Yeah. So if you say, okay, I found these credit card numbers, just go ahead and anonymize it, and then you can have Lambda functions triggered to making sure automation's in place so that any detected information, personally identified information, is then anonymized, and making sure, okay, before it goes to production, it's safe. Yeah. So things like that is easily available and easily can be done using Amazon Macie, and I encourage you to do that. It can actually analyze a lot of file formats, so text, JSON, XML, as you see here, different kinds of file formats. It can analyze, and it can actually give you more insight to what's happening. And you can then take required decisions, and making sure that you're compliant to your compliance requirements. Or if you can, if you want, you can also have custom data types. So as I told previously as well. Yeah, this is just an example of the screenshot from Macie, how it looks like. Yeah, so basically you can see, okay, there's a Swift code, there are passwords there, and all these things. So we can basically analyze using Macie and then automate to remediate that. Yeah. So this is just an example of using Macie for within your data pipelines, to discover sensitive information. So there's a blog as part of AWS, so that you can also have a look at it, and making sure, okay, if you have any sensitive information in your environments, you can automate the detection and remediation. So I will encourage you to have a look at it when you get some time, and making sure, you're running on a secured environment. Cool. So let's move on to the next slide. Next topic is Secrets Manager. As I told, it's very important that you are able to ensure your credentials are safe, and able to manage them, rotate them, and creating a life cycle policy around your secrets. Yeah, and that's a secure way of managing things and making sure if you're sharing secrets between applications, making sure that it's secured and remains secured. Yeah, and it's not that expensive as well. It's very cheap and it's on a pay as you go model. Yeah. So I encourage you to use Secrets Manager as much as you can, and don't hard code anything. No credentials hard coded within your applications or anywhere, right? So use Secret Manager service and making sure that everything is in a fine grained control. Yeah. So I've shared some insight. Okay, what can it do? Right? It can prevent devs from doing or sharing secrets and all these things, making sure it's secured, right? So please use Secret Manager to make sure that your credentials are safe. Yeah. The next thing that next service that I want to talk about is AWS config. Yeah. So as I told, you can really maintain a list of configurations that you want to. Right? So just to give you a very basic example, what is the capability of config? So you can actually maintain a template, right? So you can say, okay, I want no buckets in my environment to be public. That's the compliance requirements. Yeah. So you can set a config rule, and as soon as any bucket is public, it will trigger an alert. Yeah. And then you get an alert. And now it's upon you how to decide what to do with that alert. Yeah, I mean, or you can just tell the config to auto remediate. You can create a Lambda function, or you can attach it to the config alert saying, okay, if I see any non-compliance in public S3 buckets, go ahead and make it private automatically. Yeah, then you do a auto remediation in place. Yeah. So you can trigger that automation within config, saying, okay, there's a non-compliant resource, go ahead and make it compliant. So the S3 buckets would automatically be turned to private, and it would be compliant to your compliance requirements. Yeah. Another example is IP address open to the world, yeah, or ports open to the world. So you're using SSH 22. And you say, okay, it's open to 000, and you want to make sure that that doesn't happen anytime. Yeah. So you apply this config rule on your environment organization, saying, okay, within my organization, I want to make sure there are no open ports. Yeah. And as soon as there's an open port, you would be notified using config. Yeah. Now it's upon you how you want to remediate it. So usually what we do here is we trigger an automation saying, okay, if you find an open port and it's 0000 open to the world, make sure it's reverted back to the local VPC IP range. Yeah, so automatically it switches the range to the local VPC IP range. So it's not open to the public now. Yeah? So that's the auto remediation that you have. That's just an example. Then you can auto remediate, auto put any IP address that you would like to, and for your internal use. Yeah. So those kind of things really helps you to secure your environment. And config, these are just two very basic examples. Config can do much more. Yeah. So you can trigger highly confiscated, what do you call, or critical automations using config. Yeah. And trigger automations, and that will really make sure that you're compliant to your compliance requirements. Yeah. The next topic is tag policies and service control policies. I talked about it a bit before, making sure you have strict tagging in place. All your resources should be tagged with all the tags required. Yeah, I mean, for billing purposes, for security, as you want to manage your organization, yeah, so that you can get full visibility and you can trigger automations. You have security in place. Yeah, so that is possible using tag policies available within AWS organizations. Yeah, there's also service control policies. So service control policies are a set of policies you can define, yeah, to make sure all the accounts within your organization is secured enough. Just to give you an example, okay, if you say, okay, I have an organization within EU, yeah, within Paris or Frankfurt, you can limit the services within that territory. I can say, okay, I would allow my users to only use services within this region. Yeah, I want them only to use these services. Yeah, I don't want them to use anything else. Yeah, I want to restrict users from modifying my CloudTrail or modifying my logs, etc. So you can basically do put a lot of restrictions or put a lot of controls in place using service control policies, yeah, and making sure everything is strictly audited and controlled. Yeah, for example, if you say users from certain department, yeah, can only trigger what do you call is a launch of an EC2 machine, yeah, if the template, the CloudFormation template or Terraform template has certain tags. Yeah, they have to make sure that it's tagged properly, and if it's not tagged properly, it would not really spin up the instances. Yeah, so that's a kind of way to control the stale infrastructure, or making sure everything is compliant to your organizational requirements. Yeah, so there has to be FinOps, security operations, everything is tagged properly, and yeah, you're good to go. So it's then when you do a billing transparency, or when you do a billing review, you see, okay, I see a lot of machines being spinned up by the finance team, in the finance team with certain tags, or in the development team with certain tags. And it gives you very good visibility to your management. Yeah. But if you don't tag things properly, you will not be able to find out who did what, yeah, and who is the owner of certain machines, and where the cost goes to. Yeah, so it's very difficult. So it's very important that you tag things and making sure you enforce policies. Yeah. Some examples next is you can deny, as I said, access based on the creation of resources without certain tags. Yeah. So these are two examples. You can do infinite number of things using this. The next topic, I would say the last topic that I want to talk about is continuous monitoring alerting. Yeah, so that's very important. There are a lot of tools within AWS that you can use: GuardDuty, CloudTrail, Inspector, Macy, to detect all these incidents and vulnerabilities and scan vulnerabilities on a regular basis. And then you can combine all these, get a single view using Security Hub, yeah, and Detective as well. And then you can trigger automations, yeah, saying, okay, if a vulnerability is found, what it needs to do. And also get complete end-to-end visibility. And that's something that's very much required to have a secured environment, yeah. And we have to make sure that happens. And I would say there are a lot of automations you can trigger. So for example, if you use Security Hub, you can integrate to EventBridge, and making sure all these automations work in place and the remediations in place, automatically taking care of your incidents. Yeah. And if you are a big fan of automation, you really love it. Yeah. So AWS allows you to automate basically everything, yeah, as much as you can. So that gives you the flexibility to work on new stuff, innovate stuff without worrying about, okay, what do I do? Like in our traditional infrastructure, okay, this incident happened, I don't know what to do. There's a lot of manual stuff. But here you can automate anything. Yeah. For example, I'll just give you some example out of this, not this presentation, but something else. If you see an incident here in your EC2 machine, there's a what do you call DDoS attack, you don't know what to do, you can trigger automations to detect the DDoS attack, automatically isolate the machine, take it to a different account for what do you call investigations, remove security groups, yeah, and isolate it completely, and notifying the owners. Everything can be automated, yeah. So that's the beauty of it. So that gives the security guys more confidence and innovate and making sure that everything is secure enough. And I would say Security Hub is a tool that integrates all these different other tools And then on top of it, we can get a complete visibility of your security posture. If you're able to comply to CIS benchmark or PCI, whatever compliance requirements you have, and also trigger automation. So if you look at, there's a feature called Security Hub Automated Response and Remediation. You can use CloudWatch event rules and Lambda functions to trigger automation based on any findings, or any vulnerabilities. So I would definitely encourage you guys to go ahead and check that out. And we use that within our organization. It works really great. And so I mean, it's very important that you get full transparency. You have a good logging mechanism. You have a centralized logging. You have visibility to what's happening within your account, and you are able to remediate that. So if you follow all these recommendations, you can really be very confident that your data is secure. So to wrap it up, the things that I talked about is use Nitro instances, use encryption wherever you can, making sure there's no personal identifiable information on your account, and making sure the credentials are managed correctly, rotated, and making sure you have password policies in place. You have use secrets manager as much as you can, and enforce tagging policies, service control policies, config rules, and making sure you have proper logging, monitoring, alerting in place. And that's what I wanted to share with you today. I want to conclude this session, but just one thing, that if you are interested to know about any of these things, any of these services in detail, like, okay, John, can you have another session on encryption and decryption, for example, in detail? I would love to do that. Or vulnerability management, or any other topic. If you say, okay, you're not sure how it can be done on AWS, and if you need a deep dive technical session, please feel free to get in touch with me using the barcode on my introduction screen, and connect with me on LinkedIn, or give your feedback to the DevSecOn community. And I would be really happy to kind of to have another session on a deep dive session with you guys. Thank you everyone. And please feel free to ask any questions if you have. I will try to answer as best as possible. And thank you, DevSecOn community and T-Systems, for providing me with this opportunity. And you all have a nice day. Thank you.
Cool. Thanks, John. That was brilliant. Yeah, that was a really great insight from you. Well done, John. There are some questions. I would like to bring it up on the screen, and let's see. Yeah. So from Gogi, sorry if I said that right. Implementing these data protection measures in such a fast-changing, moving environment like cloud, having very short time for everything is very difficult. What do you think about that, John?
Absolutely. I mean, that's a valid point, and we know that, and at AWS they have providing a lot of tools. I mean, for example, I would say if you don't know what to do, and if it feels so complicated with all these tools, there's something called Control Tower. There's a service called Control Tower that you can really utilize to make sure you spin up your infrastructure with the security best practices. If you want any certain kind of compliance, you can select the guardrails. Okay, this has to be compliant there, and it would automatically spin up it would automatically kind of does the automation in the backend and gives you all the checks and measures in place. So I think you can try using Control Tower or Security Hub, basically automating all the security in the backend. So the customers don't have to go through the nitty-gritties of all these small services. Everything is integrated into these services, and basically, you can get a full transparency of what's going on.
Cool, thanks, John. There's same question from Georgi again. So, do you have any best practice on how to do it compared to physical systems? So it's just a follow-up question on the previous one.
Right. So as I said, in the link that was posted by Madhu previously, like security, identity, and compliance. That link has, they provide best practices on how to set up your have a secured infrastructure on cloud, using different services, what measures you need to take. So everything is documented, so you can download that PDF.
I think you're breaking up, John.
And if you are Security Hub, and that would really help you to. I think, yeah, can you hear me now?
John, you're breaking
Can you
up
hear
a
me
little
now?
bit. Okay,
Madhu?
you're back.
Yeah, sorry, I think there was a
You're
network
back.
glitch. Yeah, so what I was saying is there are a lot of tools available, Control Tower, Security Hub, that can be used, as well as these security white papers. There are white papers available on the Amazon website. You can download it, and that would really explain the best practices and how to use the cloud infrastructure in a secure way.
Yeah, for sure. So, John, as I ask every speaker, right? So you have a very overwhelming of security tools that you've gone through, which is pretty good. You explained about what's the right tool to use for what reason. So, what would be the one takeaway for the audience that they should take away and go back and probably investigate more, or where they have to start from security on cloud, right? Because it's a little bit overwhelming for anyone to jump into AWS, look into the whole vast of services, what they do. So, what do you advise basically to for somebody in a voice on AWS or cloud, where they can start on a security perspective?
As I said before, the very first thing is like you have to make sure that whatever you do has to be encrypted, and make sure that you start small, and learn stuff, and don't leave any open attack surface like what do you call open ports or anything on the cloud, and then use tools that can enable you to provide you with some transparency. Everybody's not an expert, so the tools that I said, very basic ones that allows you to see, okay, am I messing up, or am I in a bad situation, or just make sure that you are compliant, so that there is no attack surface that you're leaving open, and start slow. And I think you can learn stuff and try to automate as much as you can, so you can get more time in innovation and doing more cool stuff.
Cool. Thanks, Sean. So I'm looking at the chat. So probably there are no further questions, or are there any other questions from the audience you would like to ask before we wrap up for John? Okay. While they think about it, I would like to request the audience in that case. Then I have $100 AWS credit vouchers that I can give away for the audience today. So please feel free to fill the feedback form on the screen there. So it will help me to see how you gone through the session, what do you think about it, and also help us to improve. So we have three key experts here today who shared their knowledge. To our community here. So please go through it. The recording will be available later on the DevSecOn YouTube channel, and also I would more information on follow-ups. If you're interested to learn more, I would happy to arrange those sessions in the coming events as well. So it would greatly help me if you could take some time. It just hardly take 3-4 minutes. If you could share that information from your feedback, and maybe if you get lucky, you might receive $100 credit voucher from me. Don't forget to fill in a correct email address when you're filling the form. That's where I'm going to send the voucher. But I will have to randomly pick up who basically ask questions, who are more interactive, who would like to learn more going forward. Maybe it will help them to learn more security services on Amazon Web Services. So I would like to support them. So please think about it. If you'd like to learn more on how you want to get on the learning on Amazon Web Services, I would, please comment there in the feedback form. I would like to support you, and it will help you for your further learning on AWS. And you have been a fantastic audience today. You have very interactive questions, so I'm really thankful for that. And I would like to see, I don't know, end of comments like, how do you feel after this long, pretty session? Can you give some thumbs up or comments? How do you feel? And the YouTube comments, and also, feel free to mention that in the, on the feedback form as well, please. So in that case, we can sign off, and I would say I will, thanks everyone again. And I've seen most of the guys who joined today are the repetitive participants, so I'm really thankful for that, following from my first session. It will also help you because I'm organizing in a way that you can learn on steps, like how we started with containers first. We went to the basics. Then we went to a little deep dive on what the security aspects of those containers or on cloud. So now we're gonna deep dive into more of those aspects. Or please feel free to add what you would like to learn in the next event. So I'm happy to organize that. We have a very key experts available on AWS Builder community, and also CNCF Kubernetes community, Docker community. I work very close with, so I'm happy to bring them, and share the knowledge to you. Maybe it will be helpful for you guys. So thank you guys. In that case, I will end the broadcast. Thank you very much. Don't forget to fill the feedback form. So to win some surprises there. Thank you guys. Have a good day, and sziasztok. Viszlát.